When I first saw this integral, I thought it was impossible because we have that square root. I couldn't just let u equal cosine x and somehow get rid of the numerator easily, unlike sine x over cosine x. But to my surprise, this is actually doable and the answer is quite nice. We just have to let u equal something else. So why don't you pause the video, try it first before you watch the solution. Done? Okay, here we go. U is not cosine x. Well, maybe it works, I just don't know. And I'm not going to let u equal sine x either. Maybe it works, maybe you have to do it twice, but I'm not going to do it. I'm going to let u equal square root of sine x. And this is something that you just have to try it and see if it works. If it does, great. If not, maybe pick another u, or maybe try a different integration method. This right here actually works out really well, but let's get the dx first. I'll just differentiate this. We get du equal, the derivative of square root is 1 over 2 square root of the same thing inside. And then use the chain rule. The derivative of that is cosine x. And I want to isolate the dx, so multiply the reciprocal to both sides. So dx equals 2, and this thing is our u over cosine x. Okay, so here we have the integral. The top is u, and the bottom is cosine x. The dx is this. I don't think we can cancel out things nicely, huh? Because cosine x is like at the wrong place, right? If this right here was on the top, that's much better, but unfortunately not. But don't give up. This right here is an easy fix. Let me show you. On the bottom, we are about to get cosine square. Right here, I'm going to square both sides, so we see that sine x equals u squared. And cosine square, by the Pythagorean identity, this is just 1 minus sine square. And right here we said that sine x is equal to u squared, so this is 1 minus. The sine is the u squared. And then we still have this square right here. So we just have 1 minus u to the 4th power on the bottom. Right here, we get the integral 2u squared over the denominator, 1 minus u to the 4th power. Now this right here looks better because at least we can continue. And notice on the bottom we can factor it rather easily. I'm going to do that right here. This is 1 minus u squared times 1 plus u squared. And on the top, we happen to have u squared as well. In fact, 2 of them. Let me write it purposely as u squared plus u squared. Just keep them in mind, there's a plus. Now what? Here's the deal. I want to somehow produce the 1 plus u squared on the top as well, so that later when I split the fractions, this factor will cancel out very nicely. So I'm going to go ahead right here, put a plus 1, and this is a plus u squared, a positive then. Right here I'm going to put a 1, it's like adding the 1. Yeah. However, don't just add the 1, you also have to subtract the 1. It's like if you borrow money from somebody, you have to pay it back, right? So go ahead, subtract 1 right here. So that this right here is just adding 0, we don't change anything. Does this really do us any good? Yes, and very, very much. Right here, we can actually factor out a negative. I don't know why I took out the blue pen, perhaps I use it. I'm going to factor out a negative. Negative 1 factor out negative is 1. U squared factor out negative is minus u squared, like this. So that will be my first numerator. And I'm going to divide this by this thing. Yeah, so I'm splitting the fractions, and we'll do the same thing for the second one. Plus, this is just 1 minus plus u squared over the same denominator. Aha, I think we see it, right? Cancel, 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 cancel. Very, very nice. And now you can see that we're just looking at the integral of negative 1 over 1 plus u squared plus 1 over 1 minus u squared du. Okay. This right here is just negative with inverse tangent of u. And in fact, this right here, when you have 1 over 1 minus, it's the hyperbolic version. And still negative. Well, it's still the inverse though. So we have a plus. It's the inverse hyperbolic tangent of u. Yeah. Or of course, you can also do partial fractions here, but we did partial. Well, you can do it, but inverse hyperbolic function is better. All right, and finally, we just have to put the u back to the x world, and we are done. So negative inverse tangent of the u, which is square root sine x, and then plus inverse hyperbolic tangent of that, and then plus c, and then we're done. Just like that.